Hello student, I am Dr. S.L. Munde, Assistant Professor and NSS Program Officer, Department of Mathematics 3, RLT College of Science, Akola. So I welcome you in id Pathshala online class of the session 2020 and 21. So dear student, in previous lecture we have seen Cauchy higher order derivative formula problems. We have seen 4 to 5 problems on higher order derivative formula. Now in this lecture we will see next point, that is Cauchy inequality, or we can say that Cauchy estimate. Then we will see some problems on a Cauchy inequality, or we can say that Cauchy estimate. So first we will see the statement of the Cauchy inequality and the Cauchy estimate, or there may be the question in your examination: state and prove Cauchy inequality and Cauchy estimate. Okay, so what is the statement of this inequality? So if f be an analytic function in a ball whose center A radius r. Okay, so here f of z is a analytic function in a circle. This we can say that ball with a center A radius r, and suppose that absolute value of f of z less than or equal to capital M. So this capital M is a any integer number, constant number, for all z in open ball with center A radius r. Then we have to prove that modulus value of fn of a less than or equal to n factorial into m upon r raised to power n. So here capital R is a radius of the circle. Okay, so this is the statement of the Cauchy inequality. Okay, so here f of z is an analytic function in a open ball whose center A and radius capital R, and here the mod f of z less than or equal to capital M for all values of z in open ball. Then we have to prove this result. Okay, so what is the proof? We have given f be an analytic function in a open ball whose center A radius r. Okay, so this can be written as a uh, uh, whose center A radius r in this way. So this is a open ball whose center A. So this is small r radius, and this is the capital R big radius. Okay, okay. So now we will choose a small radius r such that 0 less than r less than capital R. Okay, so here let us choose the small radius r, smaller circle in this big circle. Okay, so let us choose a small radius r such that 0 less than r less than capital R. Then we can say that f will be a analytic in a closed circle whose center A and radius r. Okay, because here the function given f of z is analytic in open circle. So if the function is analytic in this open circle, then we can say that that function f of z is also analytic in a closed circle, and closed circle is denoted by b bar a into a comma r. So a is a center and r is a small radius for any r less than capital R. So this is a small radius and this is a big radius. Okay, so this is the radius of the open circle and this radius for the closed circle. Okay, now to prove this inequality, we will use the Cauchy higher order derivative formula. So therefore, by using the Cauchy higher order derivative formula, and the formula is given as at a point z0, at a point z0, fn of z0 equal to n factorial upon 2 pi I integral over gamma f of z upon z minus z0 power n plus 1 dz for z minus a less than r. So this is the circle whose center A radius r. Okay, so where gamma of t equal to a plus r e raised to power I t lies between 0 to 2 pi. So this is the statement of the Cauchy higher order derivative formula. Okay, so by using the Cauchy higher order derivative formula, we will write this formula. Okay, now we will prove at a point A. So let us put z0 equal to a. Okay, z0 equal to a. So here z0 equal to a is also satisfied the mod z minus a less than or this circle. Okay, condition of this circle. Okay, so put z0 equal to a in this formula, we get f n of a equal to n factorial upon 2 pi integral over gamma f of z upon z minus a to the power n plus 1 dz. Okay, now taking mod absolute value or taking mod on both sides. So taking mod on both sides, we get, so which implies mod of f n of a equal to mod of n factorial upon 2 pi I integral over gamma f of z upon z minus a to the power n plus 1 dz mod complete. Okay, now now we will use the property of the modulus. Okay, so by using the property of the modulus, so this can be written as modulus of f n of a less than equal to, by using the property of the modulus. Okay, so this can be written as less than equal to n factorial mod n factorial upon 2 pi I in mod I integral over gamma mod f of z upon z minus a to the power n plus 1 mod dz. Okay, or we can take the every term of the in modulus sign. Okay, so this can be written as less than equal to n factorial modulus means that is n factorial 2 pi is as it is, and modulus of I is 1. Modulus of I is 1. Okay, so by using the basic concept modulus I equal to 1 integral over gamma in f of z. So here we have given f of z. What is f of z? So here we have given in a function that in a statement f of z is less than equal to m. So put f of z equal to m upon z minus a. Z minus a also is given, z minus a, that is r raised to power n plus 1 mod dz as it is. Okay, so these are the given term in a statement. Okay, so using this term we can write these steps. Okay, so what is next step? So here m is a constant, so take outside of the integral. So r raised to power n plus 1 is also constant terms here, so this can be also take outside of the integral. So this can be written as modulus of f n of a less than equal to n factorial m upon 2 pi r raised to power n plus 1 integral over gamma mod dz. Okay, now to solve this integral, let us we put z equal to a plus r e raised to power I t. Okay, so this is the integral over the curve gamma. Okay, so put z equal to a plus r e raised to power I t, where t lies between 0 to 2 pi. So now differentiate with respect to t. So dz equal to I e raised to power I t r e raised to power I t into derivative of I z as is I dt. So take the modulus sign on both sides. So we get mod dz equal to I modulus in I r e raised to power I t dt. So take the modulus of the each term, so this can be written in this way. Okay, so we know that modulus of I is 1. Okay, so that is I is 1 e raised to power I t, that is again 1. So by using this formula e raised to power I t, that is cos theta plus I sin theta. So by taking the modulus, so we get under root cos square theta plus I sin square theta, cos square theta plus sin square theta. So you will get the 1. Okay, so this value is also will get the 1. So only remaining is r dt. Okay, so we will put mod dz equal to r dt in this equation. Okay, so then this equation can be written as or becomes modulus of f n of a equal to less than equal to n factorial m upon 2 pi r raised to power n plus 1. Integral will change 0 to 2 pi because this integral with respect to t, and t lies between 0 to 2 pi. So r dt. Okay, so here again r is a constant term, so take outside of the integral, or we can say that, so this one r and this one r will get cancelled. So less than equal to n factorial upon m 2 pi r is to power uh, n, or we can say the n plus 1, this r and this one r will get cancelled, and the integration of the dt, that is t, and limit should be the 0 to 2 pi. Okay, so less than equal to, so which implies less than equal to n factorial m upon 2 pi r is to power n, as it is, and the upper limit minus lower limit, that is 2 pi. Okay, so here 2 pi and this 2 pi will get cancelled. Okay, so only remaining here n factorial m upon small r raised to power n. Okay, so we have proved this for the closed circle. Now taking limit as r tends to capital R. Okay, so now taking limit r tends to capital R. So taking limit r tends to capital R, modulus of f n of a less than or equal to limit r tends to capital R, n factorial upon n factorial into m upon r raised to power n. Okay, so take the limit. So this can be written as, that is modulus of f n of a less than or equal to n factorial capital M upon capital R raised to power n, and this is the proof of the Cauchy inequality or a Cauchy estimate. So this is the complete proof of the Cauchy inequality, or we can say that in another name is Cauchy estimate. Okay, now we will see some problems on a Cauchy estimate, or we can say that Cauchy inequality. So what is the first problem? So first problem is, let f be an analytic function on mod z less than 5. So mod z less than 5, which represent a circle whose center is 0, radius is 5. And suppose that mod f of z less than or equal to 10. So this is the value of capital M. Okay, for all z on mod z less than 3. Okay, so this is the closed circle. Then find the bounds of the modulus of f3 of 0. Okay, so here we have to find out the bounds of this f3 of 0. Okay, so what is the solution? So we have given f is a analytic function on a mod z less than 5. So this is the open circle whose center is 0, radius is 5. So this is the open circle. Okay, so this is y-axis, this is x-axis, and we draw the open circle whose center is 0, radius is 5. Okay, and suppose that mod f of z less than equal to 10. Okay, and let us suppose that the value of mod f of z less than equal to 10 on a mod z less than 3. Okay, so let us suppose that the value of f of z less than equal to 10. The value of this is the value of the capital M. Okay, and this is the inner circle, that is mod z less than 3, whose center is 0, radius is 3. Okay, now we have to find out this term. Okay, so therefore by using the Cauchy inequality or Cauchy estimate, what is the formula? F n of a less than equal to n factorial into capital M upon capital R raised to power n. So this is capital R means radius of the open circle, that is 5. Okay, so here we have to find out the f3 of 0. So now to find modulus of f3 of 0 less than equal to question mark. Okay, so that means here we have to find out the this value. Okay, so if you observe f3 of 0 and this Cauchy formula. So here clearly n equal to 3. If you observe this both term, n equal to 3 and a equal to 0, and m equal to 10, which is given in the question, that is mod f of z less than equal to 10, that is m is 10, and r equal to 3, r equal to 3. Okay, so we have to find out the value of the f3 of 0 in a circle, that is r equal to 3. Okay, so since mod z less than 3, here center is 0, radius is r 3. Okay, so but we have given f is analytic and bounded in a closed circle, that is a closed circle with the center 0 and radius is 3. So therefore by using equation number 1 or putting all these values in equation number 1, we get equation number 1 can be written as mod of f3 of 0 less than equal to n is 3 factorial, m is 10, and r that is 3 to the power 3. Okay, so if you calculate 3 factorial means 6 into 10, 3 to the power cube, that is 27. So if you calculate, so you will get the 20 divided by 9. So this is the value of the f3 of 0, mod f3 of 0 less than equal to 20 divided by 9. Okay, so this is the first example on a Cauchy estimate. Now we will see the second example on a Cauchy estimate. So what is the second example? So here f be a analytic function on mod z less than 5. So this is the outer circle. Moreover, also we have given mod f of z less than 10 less than equal to 10 for all z on mod z less than 2. So this is the inner circle. Find the bound of f3 of 1. Here we have to find this value. Okay, so what is given? So we have given f be an analytic on mod z less than 5 and also mod f of z less than equal to 10 for all z on mod z less than 2. Okay, so this is the inner circle, this is the outer circle. So therefore, by using the Cauchy estimate formula, so mod fn of a less than or equal to n factorial capital M upon r raised to power n. Let us we consider equation number 1. Okay, so here we have drawn the outer circle whose center is 0 and radius is 5. So that is mod z less than 5 can be drawn in this way. The second circle is mod z less than 2. So this is the second circle whose center is 0 and radius is 2. Okay. So now here we have to find out the f3 of 1 less than equal to question mark. Okay, so here we have to find out the this term. Okay, so if you compare this formula to this, here n equal to 1 and a equal to 1. Okay, so a is any point which is like inside the circle. Okay, and m equal to 10 which is given in question, m equal to 10 and r equal to 2. Oh, okay, r equal to 2. So inner circle, radius of the inner circle. So as we have given f is analytic and bounded in a circle whose center is 0 and radius is 1. Okay. So then by using equation number 1, put all values. So equation number 1, f3 of 1 less than or equal to 3 factorial into 10 divided by 2 raised to power 3. Okay, so here n is 3, m is 10, capital R is 2. Okay, so calculating these values, so you will get the modulus of f3 of 1 is 15 divided by 2. So this is the value of the given term. Okay, so here f3 of 1 is less than or equal to 15 by 2. So this is the second example on a Cauchy estimate. Okay, so here we have seen most important theorem, that is Cauchy inequality, or in another name is Cauchy estimate, and also we have seen two problems on a Cauchy inequality. Okay.